it's just as simple as a group of nodes and edges representing certain entities and how they are related. So how exactly is this information stored? We've mentioned graph databases, but of course, graph databases are used to store graph data. So it's intuitive, just like that. There's nothing special here. Graph data is stored in something called a graph database. So examples of these, there's Neo4j, which is the biggest, I would say the leader in storing this type of data. And of course, there is also some other triple stores. They're called triple stores, but they also handle this type of data. So a graph database, of course, relies a lot on relationships, as I think I've described. And the relationships are used to make inferences about that data. We might want to ask a question: who is related to this person? Who are the people following this person? What businesses does this business, follow, or what businesses, what customers are for this business? So you can represent a lot of information about businesses, about patients in a hospital, about banks, about people in the country, and population data. So we use relationships to derive connections between all of these things. So compared to SQL databases, which is the older architecture of databases, it doesn't store things using nodes and edges. So it stores things using tables. And that's a bit complicated to actually visualize, and I can quickly demonstrate that. So we have a quick SQL database here. And it stores a database. This is just like an SQL database, but it stores information as separate tables. So there's a table of maybe customers for a certain business, maybe the staff members of that business, the orders in that business, the stores that business maybe sells to, and items that people have ordered, So to derive relationships between these tables. So these tables are stored separately in an SQL database, and then relationships are defined between the tables. But it's not very intuitive. If I ask you right now to, kind of deduce how this information is related, it's very hard to understand how that is. So that is exactly what graph databases, allows us to do. It gives us the power to define things intuitively, the same way we think about it as humans, nodes and edges, how things are related together. So graph databases consist of two technologies. One technology is, called the graph storage technology. This is to store and manage the graph, and then there's a graph processing engine. So the processing engine is the one where we shall be performing the operations for creating, sorry for the typo, creating things in that database, reading the things in that database, updating the things in that database, and deleting things. So these are normal operations. If you've used any application, you should be able to do all these operations in an application. Create a post, read your posts, update a post, and maybe delete the post. So these are the two aspects of the graph database. And basically, this is what governs graph data. So as unintuitive as it might seem at the moment, graph databases are in more places than you think. And they actually utilize a couple of things that we actually use today. Our social media is this. I've tried to list a couple of examples here. So Visa as an entity, it's an organization that deals with a lot of banking data. These cards maybe are linked to businesses, they are linked to subscriptions, they are linked to banks, and so a lot of information is being captured, but it can't be captured in tabular format. It needs to be captured in a rich structure, such as a graph, so that you can be able to detect things like fraud, do some interesting machine learning applications, as we shall discuss later. Machines can start utilizing this data to make decisions for you, which becomes a bit easier. If you represent the data poorly, it becomes a bit hard, and you need humans to understand it because it's not machine interpreted. So other organizations like Google, every time you type something in Google, I'm sure you've seen the magic, something always predicts the next word that you're going to type. And you get a collection of things that all seem connected, So Google is actually a very big graph of information that we are just querying to get onto what we want in a smart way and very fast. So, Meta, Instagram, Facebook, whatever they call it now, it also, uses graphs. So Facebook is one of the first companies that actually adopted graphs for storing all the information. So the way they can predict that you might know this friend, or you might know this connection, you might know this person, or this might be your friend, things like that. And that's how they build all that, all those decisions through graphs. So another thing that is intuitive is the LinkedIn. LinkedIn has the connections of professional relationships. So LinkedIn is just a network. So how can they build the best network for you that is appropriate? You don't want to be a doctor and you're receiving connections from people, maybe I don't know, in maybe astronomy or something. So you want to see people relevant to you. And the way LinkedIn fine-tunes your profile to give you people who are relevant to you is through graph data and those relationships. So if you follow someone, we can look at that person and then we see who they also follow, and then we can deduce that is that relevant to your profile. So we read your profile. So there's a lot of data that is connected to draw decisions. Wikipedia is also another area where this graph data is. And another perhaps more interesting aspect is our DNA information. So to analyze our DNA information, because DNA is just a bunch of proteins, arranged in a certain structure. So biological information fits very well in a graph structure because they are just things connected. Cells are always connected together by maybe a certain chemical process. Our DNA can be disassembled with the data and the sequences and represented as a graph. And then, machines can be used with doctors to analyze places to target medicine, maybe in our bodies, so things like that. So they use this technology a lot in developing most of the vaccines that we're using for COVID now. If you want to read more about that, you can find the information, but basically biological data can also be represented as graphs. So as you can see, I've left out a couple of things. WhatsApp, all of these guys utilize graphs to make things more efficient, easy to work with. So you can realize that you've used graphs one way or the other. So I mentioned that we can use this data to, we can use machines to help us analyze data and make some good decisions and conclusions. So of course, how machines help us is through a process called machine learning. And machine learning with graph data, what does it take? So because it's a new architecture of storing information, it's not very friendly for machines. So there is some massaging and waxing you need to do to the data before you actually push it to machine learning algorithms. But it's very powerful for machine learning. So we need to figure out how to connect the two. And part of my research tries to answer this question, and we figure out strategies to do this. But in the context of whatever we're talking about, I'll talk about some of the tasks. Why would you even want to do machine learning on data? What are some of the things that you might be able to discover from the data? So of course, I say that you have a graph, you have a graph of things, connected things together. So sometimes new things come into this graph, like when you join Facebook, you'll be a new node in the graph that already exists, Facebook's graph, So sometimes they want to classify, where might you belong? Are you a teenager? Are you old? So the first time you come on Facebook, they'll give you suggestions, friends you might know. If they're trying to classify it, so they're doing a node classification task, and you might actually get some pretty good suggestions. You have not used the app at all, but they suggest to you maybe some of your schoolmates, some of your workmates. So it's smart, we are deducing some data from the graph to predict where you might belong, people who might be relevant to you. So that is called a node classification task. We get you and we classify you and we give you a class of maybe you're a teacher. So we classify you somewhere close to teachers, and you'll start getting recommendations of, teachers in Kerere or wherever they are, or in Kumba or in other schools, depending on where you're teaching. So another task is link prediction. So link prediction is basically a task where you need to predict relationships between ages, similar to almost previous one. When a new entity comes in, or when we have entities but we don't know how they relate together, we can start to predict how those entities relate together. And this is very powerful for proteins and drug discovery and our DNA. Sometimes different structures of the DNA, but you don't know how they react in case you bring in medical, maybe drug. So if you bring in a drug, you want to understand how that drug interacts with whatever was inside. So you deduce a relationship between there. And that's link prediction. So you basically try to predict the correct links between those two categories. And then you can know how maybe the new drug that was introduced affects whatever was found there. So another category of tasks that you can do is called link-based clustering. So here you're clustering things depending on how familiar they are behaving, So let's give an example. Imagine this is, a graph database of people in Stanbic Bank, So we have every entity and we have relationships of the transactions they have performed, and we have a flag, are they fraudulent or are they not fraudulent? So imagine this guy has been doing some weird stuff with Stanbic. He has been flagged for doing some fraudulent behavior, but the bank is still trying to figure out, should we ban him? Is he actually trying to cheat the system or something? So this guy, we know the transactions that he has performed and some of the things that are in those transactions. So when another person starts doing similar transactions to this guy can be brought closer here. So they stay together. So they start forming communities. People who behave the same way start forming communities. And you can formulate those communities using certain algorithms. And then you can start to discover that, oh, there's a cluster here of people who are behaving weirdly. So if you're out of this cluster, you're not behaving exactly like these people. But if you ever come close, so you get on the radar of the bank to know that, oh, this person was this side, but he's starting to behave like these, thieves. So typical machine learning, as I've said, machine learning doesn't work very well with graph data. So a typical pipeline of machine learning, you always have raw data, the normal data that is not even graphs. You structure it in some way, and then you apply some learning algorithm, and then you produce, the model that is going to do your prediction. So to achieve structured data that is ready for machine learning, it's actually very complicated. My connection got a bit unstable. If you can still hear me, okay. Okay, so we do some tasks to basically achieve machine learning to work with these models. That is something that we're doing in our research, and I won't go so deep into that, but you can read more about it. But basically, all that happens is that, so why machine learning fails to work with graphs is that it doesn't understand this type of data structure. So this is called symbolic data. So symbolic data is not very good for machine learning. You need to convert it into numerical data. So numerical data is things that everyone knows, a vector, a matrix, so that is numerical data. So how can you convert this to numerical data? So the goal of, when we get this raw data to prepare it for machine learning, the task we are doing here is to convert all the nodes in this graph into vectors. So we learn a vector for each node. So this node, we learn a very big vector of numbers. And this is a highly specialized area that you can read more into. But anyway, to make the long story short, all the nodes are converted into vectors. So you'll have, if you have 1 million nodes, you'll have 1 million vectors. And then those vectors can be pushed towards the machine learning model to do something. So here, imagine we have this graph and we've learned the vectors of all of the nodes. And then if we plot these vectors, you'll actually start seeing these communities. So you'll start seeing nodes that come closer together, and you discover that they actually have the same patterns. Maybe if it's a banking system, there are people who are performing the same transactions. If it's agriculture, there are people maybe who are growing the same crop. So this allows you to make decisions, for governments, for different things. Maybe they want to understand what is the most underfunded, agricultural commodity. So that's how, things become smarter. So what's the roadmap towards graph databases in any economy, Uganda or anything? So as I've said, graph databases allow us to link a lot of information. So we can have data from the buildings in the city, their parking, whatever, their building models, architectural models. We can have our health data for all the patients in the country, our census data, vaccination stuff, our geographical data, and we can also have security data, education, banks, finance. So you realize all of this data is different. It's captured differently, it operates differently. So we come up with a structure of linking it up, and we link it up using a knowledge graph. So there's a mechanism for that. And without going into further details, the output is a graph. So the goal is to get all of this information and represent it as a graph. And then now you have a federated graph model. So you now have data that is linked and you can do some downstream applications. Yep. So I think I presented this on my last conference at Kumba. And just into the future, what happens when we have data about everything connected? Just a car that is maybe somewhere in the city. Instead of so every time we see a car, we've seen its number plate, we know its details, we know who is driving it, so you can easily fight crime in the city, because these days cars do anything in the city. In Kampala there are shootings during the day, there are bombings. So currently it's policemen sitting in the CCTV office forwarding and rewinding footage, but we can actually have machines analyze all this footage data, because this data is stored in our databases. Everyone has a national ID, everyone has a driving permit, everyone has different types of information. They have a registration card. So can we capture all that information and we use it for such interesting tasks? When a CCTV sees footage, it's literally analyzing everything. So if, let's say, one of these people, put a bomb here, it's easy to just request the model to say that, can you find for me all the people who are in this vicinity, who are in this radius? So the model has seen everything, the CCTV has seen everything, and literally you can automate an SMS to go to everyone's number, whoever was there, because we have the data captured by the CCTV. You don't have to go and forward footage, get a picture, look for the phone number from MTN, from Airtel. So all these organizations can collaborate into something like security. So this is just a quick use case that I gave you just to make things a bit more intuitive when you've captured data properly. So enough talking, I think. Let's get to see things in action, and let's do some code and see things a bit more intuitively. Feel free to put some of your questions in the chat, and we can see how we can address them accordingly. I'll take short breaks to address some of the questions that come through in the chat. So for our hands-on session, what technologies are we going to use? So every time you're doing a development task, you need to have a couple of technologies you're going to use. So for us, we are using something called the Grunt stack. That's what I'm going to demonstrate today, because this is what allows you to work with graphs, in today's application. So you can build an application from top to bottom using this stack. So GraphQL is just the API technology that is going to allow us to query and ask for things in that graph data. Give me this, give me this, give me people connected to this, give me this. So we use GraphQL to do that. React is just building the beautiful things that the customers see when you open your phone. What do you see? The client, the buttons, and all that stuff. The form to fill, the place where to search for something, that is React. Apollo is something that allows GraphQL to work with React. So it's just a mediator between these two technologies. And then Neo4j database, of course, is the database technology that we're going to be using to model, store, and query our data about the graph. So this guy keeps talking to this guy, and this happens behind the scenes. For you, all you do is you get the results here on your screen, and you see, you're happy the application is working, but these guys are just talking to each other with the help of this third guy. Yeah, so that's basically how it operates. I can just quickly go through it. So you have a mobile phone here that you're seeing, the React front end, so the beautiful stuff. So you ask this guy you make a request. I want maybe, give me movies by a certain title. Maybe I want a title by Matrix. Find for me all those movies and give me their title and give me their year. So you've made a request. Someone needs to send that request. So GraphQL will send that request to the database, and the database will do some matching, and then it will return for you the results. So the response comes back and, oh, you return back the data. So you got a movie called Matrix Reloaded, and the year 2003. So because you asked for, I want the title, I want the year. So you can delete the year and you only get back the title. So GraphQL allows you to request for things intuitively. Only ask for what you need and get only that. This is different from other APIs where they are very complicated to request for things from wherever you stored them, because you need to, every time you make a new request, you need to design the architecture with an endpoint. But basically, this is the Grunt stack pipeline, and that's how these guys talk to each other. And I'll quickly take just a minute for anyone with some questions to push them forward, and then we can probably proceed. I'll just quickly look through the chat. Okay, so Ivan Begumisa asked the question, is blockchain technology based on graph data? That is a question of no, it's not. So blockchain operates almost in an architecture of, because you have nodes in the blockchain, and these nodes talk to each other to make a transaction happen, maybe a Bitcoin transaction or any crypto technology. So there are also nodes that are operating in the chain, but those are not the nodes that are the same in graph database. But of course, you can apply blockchain technology inside, graph databases, and there are technologies for that, and you can do that. But blockchain technology is not based on graph data, but it's based on the same concept of things talking to each other. So another question that came in is, do we still use keys in the graph database? No, we don't use keys. We actually use relationships to traverse things. So we use relationships to look for things. So it's like you're walking through the graph, asking for what you need as you keep walking through. So the more you walk through, the deeper you can keep going and asking for different things. So we don't use keys. Sorry, someone said my network is cutting. Please text again if it's not yet okay, but I'll try to assume that it's doing better now. So someone asked,
Kevin, your network is all right. Maybe the person needs to check theirs.
Okay. So another question that I've received is, can someone download Groundstart on their laptops? Perfect. So I think I'm going to come to this here. And just to quickly run through the stack. So I think I've shared a quick link here called Groundstart.io. So when we quickly run to, I'll just quickly close this. So Groundstart, it's not a software, but it's just a group of technologies that you need to configure one by one so that they all operate in unison. So if you've used something like Node.js for working with different libraries, JavaScript, you'll be able to install this. And I'm going to quickly go through how we can get this whole thing set up. So you can download it, but you can get reference to what each technology is doing. So these are basically libraries, and you install them one by one using NPM, which is a node package manager. And we shall look into that. But yeah, if you want to get any reference documentation about this, you can quickly go to this page to get started and understand how to, get started with things. So they're also using the node package manager, NPX, to do the installation. But here they are just creating for you a template to get started with. And if you want to also see that template, there is called the Groundstart Starter on GitHub that you can, I think, quickly spin up. So it quickly gets you started on how to build, an application on, that's using these technologies. So this is like the template to follow. So I'm going to quickly go through each of the. I think the only technology that can allow you to download is maybe Neo4j, which is something we're going to play with a bit. So the time might not allow for me to wait for everyone to download it because it's a bit big. But Neo4j database can be used both in the cloud and or you can actually create your own instance on your local machine, and then you use it on your local machine. So there are two options. There's one that is fully managed by Neo4j as a company. So it's called Neo4j Aura. So this allows you to almost have something like a Google Drive where you can use a graph database there. So Neo4j is like a Google Drive for graph databases. So it's fully managed by Neo4j. You don't do any maintenance on it, and it's meant for people who are developing applications using this technology. So you can always go to Neo4j Aura to quickly start up something. It's for free to get started for just about, I think, 1 million nodes, and 1 million nodes are so many for a quick startup application. But just a quick example of a database that we have. When you've created a database, you can have it and then you can explore it. So you can see the nodes in that database. I think for the free version, they give you, you can create as many as 50,000 nodes and as many as 175,000 relationships. So for a small application, you can't even consume this unless you're building maybe an app for maybe Monaco or something and a big organization. But yeah, so Aura is the first option for downloading Neo4j. The second option is to download Neo4j Desktop. So Neo4j Desktop allows you to play with Neo4j on your local machine. So it's not in the cloud. So you need to do some bit of configuration to make sure that it works in your application. So this is the second option, cloud, local machine, and the other one is called Docker. So Docker allows you to create a small container. Think of it like your small little box that you put on your computer, and you can create a Neo4j container inside it. So you can use Docker, and I think they provide their official Neo4j Docker image. And the configuration of this, I'll quickly talk about it in technical hands-on. Yeah, let me see if there's any question. Can graph database be used with BOT or LTP, OLAP? Sorry, Phillips, I think there are a couple of acronyms here that I'm not properly understanding. If you can elaborate, then I'll be happy to answer this. Yeah. Okay, let me share the links. Someone has requested for them. Groundstart Io. Neo4j. Or okay, so I've shared the links in the chat. Sorry. So I think Phillips asked, can graph databases be used for online transaction processing and online analytical processing? Yes, yes. So that can basically happen. And this is actually used quite a lot in fraud detection, to analyze behavior, consumer behavior. So let me give you an example of just a very quick hypothetical. And I'll quickly just get a simple graph here to demonstrate this. Sorry. Okay, so imagine this is, let me just get my pointer. So imagine this is someone who wants to perform a transaction online. And the nodes that are close to him are basically the transaction history that he has ever done. So maybe this is a transaction on a certain website, a transaction on a certain website, a transaction on a certain website. So with this person's node, we know all the transactions he has had and the relationships to those transactions. So what we can do is that each of those transactions can have a field such as time of transaction. So people rarely do transactions at 2 a.m. So if all of the nodes, the transactional nodes around you as a customer are done somewhere before 10 p.m. and one day you ever do a transaction after midnight, you might actually try to pay for something after midnight and your card just rejects. It does not reject it because the bank is offline or whatever. It's just that that behavior is new to them in the graph. So there's a new node that has come in the graph and it has different behavior from what was existing. So you can actually almost be told by the bank that try again tomorrow, because maybe they are saving you from a theft. Maybe your card, so they assume that this person has never performed a transaction after midnight. What day of the week is it? It's a Friday, so maybe he's out, he has lost his card. So maybe someone is trying to buy something, maybe in a bar after midnight. So this is some of the analytics that are happening, but it's because of the relationships that are existing around here. And even if you don't have enough data as a node, so we have a customer, but you haven't performed a lot of transactions, so we don't have enough information to know when we need to safeguard you. We can look at other customers who have done similar transactions. So we can say this customer stays in Kampala and this one stays in Kampala. So this guy has a lot of data about his transactions. So maybe he might have the same behavior as this guy in Kampala. So we can make decisions for this guy based on the data of this guy. And we can help you. If someone is in Mobende, so things are different. If this guy stays abroad, maybe time zone changes and maybe he performs transactions after midnight. So the more information they have about you, the better the decisions become. So yes, online transaction processing can happen using graphs, but of course you design the logic for that, but the possibilities are endless for doing that. Okay, so I think I'll try to move on. Let me answer at least 2 more questions and I see how we can go forward. Yes, I think, I don't know if I pronounced your name properly, Guilo. Yes, he's asked that, thank you for the presentation. I wanted to find out whether GraphDB is also about social network analysis. Yes, graph databases are used in social network analysis for things like link prediction, predicting who you might be connected to, what relationships you can build for you with other people on the network, to know if you flag someone's content, maybe on YouTube, if you flag a certain YouTuber's content, but you're alone, it might not have so much impact. But if that YouTuber gets so many people flagged, his node maybe in the YouTube graph gets new information that says maybe he needs to be banned. So things like that. Those decisions are made using graph, and we can always try to understand the people who flag this YouTuber. Where are they from? Are they from Africa? Maybe in Africa we don't. There's a bit of homophobia going on. So maybe you'll find a lot of people flagging content about homosexuals, lesbians, a lot from the African community. So you can easily find out those analytics using graph data. For each YouTuber, we can have the comments he gets, the nodes of comments that he gets, and each of those nodes maybe has a demographic, and we can be able to understand that maybe it's just a bias from a certain cultural background or something. Yeah, but here you can do social network analysis for that and a lot of other types of analysis. Okay. Another question, will graph databases replace Rdbms in the future? I assume you're talking about relational database management systems. They are not here to actually replace. They are more to complement. Every time I think we think about a technology and we assume that it's coming to replace, people take it bad. So the old relational databases are not going anywhere, but they are being complemented by graph databases. It's almost like crypto complementing the fiat currency. Crypto is not trying to replace fiat. And I think whoever is trying to get it in that context probably, gets it wrongly, and sometimes they're a bit biased about it. But these technologies are there to complement each other, because one always has weaknesses and another comes to fill in the gaps. So graph databases can also have their own weaknesses, and there are so many, and maybe Rdbms are actually still the powerful, technology to use instead of graph databases. So as long as you understand the strengths and weaknesses of each, you can know how they both complement each other. And graph databases now are offering a lot of support for integrating with relational database management systems through REST APIs and through a lot of mediations with the queries. Yep. So I hope I answered your question, Phillips. So I think we've dived a couple of questions. So I'll quickly rush back to the presentation. Please keep throwing the questions there and we shall discuss them as we keep going. So where exactly were we? To look into the code and how things are working and how to get Grunt stack set up. So I'll just quickly get this out of the way. And we shall bring our environment. So I'm using VS Code, and VS Code is just a programming environment where you can, write your code for any type of application and any type of language. So I'll just quickly make the screen a bit big to make things a bit more visual. I don't know if you can see my screen properly on the coding side of things. Please, someone just confirm.
Yes, we can see it. Okay,
perfect. Thank you. Let me just quickly close all this so it doesn't get in our way. So what we are going to be building, I think, let me give context exactly what we are building. So we are going to be building this guy, the Graphql API and Neo4j. So in the technology stack, that is Neo4j and GraphQL, these guys that keep talking together to make where you request for things. So we are not going to talk about the person who requests for things, but we shall demonstrate how this guy requests for things. And this guy sends the message to the database. So we are going to work on the API and the database. So I'll quickly demonstrate the building blocks of this. So this is just a quick project that I set up somewhere on my disk, and I can quickly just show you that project. So it's Graph Database project. It's just a normal file folder that I set up in VS Code, and I've started to populate the project. So let me show you some of the building blocks inside this project. Of course, we are building the server side of things, the one that performs the transaction, serving and everything. So the server has a couple of things to look out for. So one of the most important things is the GraphQL, and you can arrange this any way you want. This is just my structure that can also be useful for you, for your other tasks and projects. So what we have is GraphQL. And this one holds everything related to that messenger that is going to be asking for things and the messages and whatever. So this messenger needs to be described for, what exactly are we going to be storing in our database? What things are we going to be storing? So the way you create these entities, and these are going to be almost similar to what I demonstrated in this chart. So these are the entities. So like this node is an entity. So we are going to be defining each entity, what are its attributes. So if we say there is an entity called person, we need to define attributes. This person has a name, maybe an age, a background, a national ID, visa, banks that is related to, things like that. So that's how we build entities. So, and those are called type definitions. So when we're defining type definitions, I'll just quickly, delete a couple of these so we can quickly create some from scratch. And just keep simple one here. Okay. All right. So I'll just quickly turn this off for a bit. So this file is just to define the entities that we are going to be having in our data. So we define different things. So I'll just quickly ignore this. Let's start creating ours from scratch. So let's say we are building, let's find a use case. We are building a database for NERA. So the first thing we have, a NERA database, what does it have? First of all, it has people. So we can say it has a person, or could be a citizen, because the only person who can have a national ID is a citizen. So we can start to define our types. So a citizen has a name, and this should be given a data type. So a string is just text. And when you put an exclamation mark, this just means this field is required. So if you ever, let's say you're trying to input a new citizen in the database and you're providing the name, if you ever miss the string, the database will shout at you, hey, I need this field. You can't give me a citizen without a name. So that's how we define. So we say the name, maybe the age. The age could be a number or a string, but I'll just leave it as a string on it. And I'll try to make them not required for now, just to demonstrate the use case. We shall say maybe NIN number. So the NIN, this could be also a string, because it's a collection of numbers and letters. We could also have maybe the car. So this could be, let's say driver's license. This will also be a string. So let's try and create another entity. So let's imagine this is all a citizen needs, in NERA. And maybe also something about being flagged. Is he flagged by maybe police, maybe the criminal investigation department has a flag for everyone. If it's true, it means you're wanted. If it's not true, it means you're not wanted. So a Boolean data type. So these are all data types. A string is just text. Boolean is a yes or no, true or false value. So basically that's the information maybe NERA wants to have about every person. So we also have maybe what other entity can we have in the NERA database? So maybe we say a NIN. So maybe all, the database has all our NIN cards. So the NIN maybe might have the NIN number. So the NIN number could be a string, and maybe expiry date, let's say issue date. Issue date. Let me just say it's a string for just simplicity purposes, but you can actually provide a data type called date. So that should give you, but I'll just keep it as a string. String can have the expiry date. And I'll quickly just show a quick example just to get intuition about this. Then we can look at a real life example of an e-learning system that we've done using this technology. So NIN number, issue date, expiry date. So this is cool. So what we want is we have entities. So we have a citizen and his NIN ID. So rather than having the NIN as just a string, we can actually create a relationship between these two entities. This is where we are now building relationships for Neo4j, So if we now say, instead of just providing the string, we can just link up these two guys, and there's some vocabulary for that. So I'll just quickly just get some text from here. So we are saying this NIN attribute of the citizen is actually linked to this type definition called NIN. And these are different. This is just an attribute, and this is actually the type. So NIN, and we are creating a relationship, and we are saying has national ID. So what we are doing here is we're trying to link up the citizen to the national ID, and of course we provide a direction for this relationship. So if it says out, it means it's coming from the citizen. So citizen has national ID, so that relationship is coming out. But if we say is national ID for, so here we're just saying that this national ID is a national ID for this citizen. So that relationship is defined as in. So it's basically entering the entity. It's a bit hard to visualize, but when we start creating this stuff, it becomes a bit more formalized. I'll just quickly make it as it was before. So has national ID, direction out. So right now, if we save this, so these are the type definitions. So every time you're requesting a request, you say, find for me all the citizens in the database and give me their name and age. So you can skip everything else. So the GraphQL API just has the message that it needs to ask for in the database, but it doesn't know how. That is where our second guy comes, the resolver. So resolvers are meant to define the logic of how you're going to request for that information, wherever it's being requested for. So I won't go so deep into the details of the resolvers and how this GraphQL request, the GraphQL request is converted into the request. But basically, we have libraries that actually help us do the heavy lifting for that. And I'll talk about one of the libraries to do that. But basically, in a nutshell, you have the type definitions that define the things that are going to be in you're defining the types in your database. And the resolvers define how we are going to be fetching and changing and deleting and doing all those things. So what we are basically trying to operate here is this. So the graph processing, creating, reading, updating, and deleting. So all these things are basically done by a resolver that instructs how can I do this task that you've requested for. That is this middle part here. So we write a query and how it's requested for and returned back. That is basically what is done by a certain library. So we've finished whatever is inside this GraphQL. That is literally it. So you need to understand your business objectives or your application's objectives. And then you define how your data is going to look like. So you first define all of these things. So to give you an intuitive example of something that I think we shall talk about that later. But basically, that's what we have for the GraphQL. So the next thing is ignore these node modules, not important. We have a .env. So the .env, I'll come back to it and basically what these variables are. So the most important file is this GraphQL folder with the type definitions and resolvers, plus the server file. So this file is defining all the logic of instantiating our database, starting the server, and having something to work with. So we are basically trying to create this guy. this whole guy to operate and start working with this guy. So to do that, this server file will have a couple of course, inputs, and there are some libraries. So I'm going to go through each of them and what they basically do. So someone who asked the question, how do we install Groundstart? So this is the process. Here we're just importing all the libraries that are needed for the Neo4j and the GraphQL part. So there are some libraries, and these are installed in, they are defined our dependencies here. So the first library that does the heavy lifting that I talked about for making the request automatically is called Neo4j GraphQL. And you can always find these libraries on npm, the node package manager, npm neo4j GraphQL. Yeah. So every time you go to npm, you can always search for a library. So that is how you install it. So you can always copy that command, npm install, and then so you can search for any package depending on the technology you're operating with, and then you install it. So to install it, you can go to the terminal and then maybe copy that command here. So npm install neo4j GraphQL. I can't do this again because I've already done it, but basically what this is doing is installing this dependency. So that's how we install all these dependencies. And if you really want to install the exact version, because versions can break, I can make a tutorial using 2.10, and by the time you try to run this on your own, it's maybe on 2.5. So 2.5 might fail because there are some differences. So it's better sometimes to follow exactly what I did in the tutorial. So I've used version 2.1. So when you're installing also on your machine, you can say 2.1.0. So it will install the library, but go back in reverse to install that version that you require. So these libraries, so Neo4j GraphQL does the requesting every time you make a request. And just to make this a bit more intuitive for someone who doesn't really operate maybe in computer science. So every time you make a request, let's just quickly show requests that everyone knows, in Google. So in Google, if we can look at the console, every time you type something in Google, you're making a request. So I'll just clear all these requests. Let's say teachers in Uganda. You realize that they're building up a search. This is a search query that they're building up. So every time you're searching for something, there's actually a knowledge graph that is being used to populate the next, possible keyword that you'll use. But to fetch your data from wherever it's coming from, a request is actually made. So let me just clear this. Maybe you can see the request being made. So, yeah. So the data gets back to you, and usually I won't traverse these requests, but basically this is how the data came back. So they return for you a lot of data that you can understand. Impact of COVID-19. It's another request. So you can always understand how the response came back and the different requests. So you as a user, you never see this backside of things. You're just making requests. Every time you ask for something, you make a request. So that is exactly what we are also doing here. So this library converts all of these things and I'll show how we request for things. But every time we request for something to talk to Neo4j, that library comes into play. Apollo Server Express, remember how I said there's some guy who allows us to work with the client. So Apollo Server Express is something that allows our server to work with the client where you write things as a user. So body parser is just a certain middleware. Compression comes in when you need to start uploading files in your system. So compression calls, those are all used for file uploads and some request nitty-gritties. The most important ones are GraphQL. This is the library that allows you to work with GraphQL inside this program. And if you're going to be uploading files using GraphQL, you'll also need this package. So I've summarized all the packages. So anytime you actually want to start with this project, you don't have to reinstall this again. You just have to go to the directory where this folder is, and you just do npm install. So it will install everything as I worked with it today. So I'll post the code on GitHub, and then we can see how we can go ahead with that. So those are the dependencies, and those are the things that we have basically imported. So we import them in our server file, and each of them does something. So remember how I said that I'll talk about some of the dependencies. So there's one called .env. So .env, every time you type something in your code, so this is just a security, I would say, hack, but it's known in the developing community. As I've shown you, every time you do something on a website, it can be inspected by maybe hackers. So you could be on Standard Bank paying something, and when you're on this page, So someone could be somewhere sniffing whatever you're doing. Maybe it's a hacker trying to hijack your, visa information and whatever. So the way Stanbic protects you, so in the back end, I can always go and try to, inspect the code of, whatever is trying to, run in whatever basically is operating on your screen. I can try to go and inspect what's happening in the code behind. So if I find any sensitive information like your password or your visa, code or a CVC, your account number, I can always hijack that information and keep it somewhere, and maybe I use it maliciously. So it's not good to write sensitive information in your code because it's always easy to intercept. So we can always use a trick and we can hide those variables. So instead of, let me show you one example, just to quickly rush ahead of myself. There is somewhere we basically write a password. So there is a function here that takes, and this is the function that starts our database, but our database needs a password and a username. So I'll just quickly delete these. So this is our code. Imagine we say that our code is taking a password and sorry, the username is maybe Kevin. And the password is going to be, give it to me. So if you leave this in your code and the code is compiled and put on a website, someone can actually hijack this information because you've typed it directly inside this. But we can actually use something more special to basically hide this information. And it stays on our computers. It never goes on the internet, as a developer. So we can always hide that information inside variables. So we use environment variables. So we are saying the username is going to be stored in something called process.env.neo4j-user. My password is going to be stored in process.env neo4j password. So that is basically the use of this env. So every time you say process.env and you type something here, this thing needs to exist inside your .env. So this is where we put all our secrets. And of course, there's nothing here, so you can always look at this. But yeah, this information is basically now hidden and you can use it inside the application secured. So every time you put this, when you run the code, this will be put there, but in a more systematic way, it's not easy to hijack. So that's what the .env does. So it sets the environment variables from the env file. So we have a couple of variables in this file, and we're just saying, hey, before we even start, pick them from here and start putting them inside here, but not in our code, but just inject them when we're going to run the application. So that's the first thing. The next thing is to basically start our server, and we're basically going to write a function that starts our server and does all the magic. Let me just quickly delete this. So this server has a couple of things so that we need to work on. So there's a driver. A driver basically connects your server to the database. How are you going to talk to the database? So this is a driver, and it's built with a library called the Neo4j driver. So there's a library called Neo4j driver that allows you to connect Neo4j to these types of applications, and then you can use Neo4j in the application. So this takes the URI, and the URI is like where your database is being hosted at the moment. So remember how I said that we can usually store the database online, Aura. So Aura has, you can always get the URI of your database. So this is a URI. We can get this if we just copy this and we put it here, or we put in our .env, and we put our username and password. We shall connect to the database on the cloud. So we shall start storing things there. So the driver we shall be building will be to connect to that database on the cloud. So let me just quickly remove this also. Yeah, so that's the first thing that I'll just quickly take this back. Yep. So when we are building the driver, it takes what database you want to connect to and provide the authentication for that database, because you just can't enter a database. You need to authenticate yourself. So we create the driver, and then we create a Neo4j GraphQL object. So this is more like we are now building the connection and instantiating it. So this one will take a couple of things. It takes the type definitions that we defined, our messages that we want to, our type definitions. So it takes the type definitions, how to resolve them. It takes this driver, and it also takes a configuration object. So the configuration object might just be, something you might configure anything inside here, how you want your database to interact with the GraphQL. Maybe you want to put some security mechanisms, you can always put them here. I'll just quickly actually comment that out because it's not important at the moment. So after creating this Neo4j schema, we then create the Apollo server. So the Apollo server will return a context object, and this context object has interesting things that you use every time you make a request. So every time you make a request, there's context. So context is something that is used in applications to define where are you in the application. I'm sure you've sometimes gone to Gmail and sometimes you need to log in, and sometimes you just come and you don't need to log in because the website still remembers your context, still remembers that the context that you're in, you're still logged in. So you can always just quickly run back. And so this object is also inherited here. So the schema is taken by the server, and then we can quickly start the server. So we actually start the server. So we say server.start after taking all of this information that we needed to work with, and then we can initialize some extra things. So we inject in some new things in the server to spice things up. So one of the things that we are going to inject in the server is compression. So compression is just when you're going to be uploading files in your server and you don't want to have a lot of issues, you need to apply some compression. This will help you make the requests better. And an important one also is to maybe you want to define how much a file size can ever be. So we are defining the server, and the server needs to be told everything it needs to do if it ever gets an instruction. So we are telling it, if you ever get files, make sure that the maximum file size, this is actually 100 megabytes. Don't accept files more than 20 at a time. So we are just injecting in some interesting things, and that is called middleware. So this is file compression middleware. This is some middleware for passing JSON. Some middleware for file uploads. And then here we are just defining things now on the GraphQL. So we've already defined all of the things for Neo4j to connect to Neo4j, but we also have to define things that connect to our GraphQL, API, the guy that talks to this guy continuously. So where did we get these things? I'll just quickly run back to that. So I said that Neo4j can be used in the cloud, but you can also download the desktop application. So I have the desktop application here, and we can quickly create a database inside there. So in Neo4j, when you open it, you can actually add and you create a local Rdbms, and we can say graph db Nkumba. And then we give it maybe a password. We can say maybe, but I don't know if that's allowed. Let me just say, let me in. And we can choose the version of the database. So these versions determine how the code will operate. So you need to use maybe the latest that is fixed, and then you create the database. So when you create it, I won't create it, then you can be able to start it. You can join here, and then you can start it. And when you start it, you're able to basically run the application. So that is basically literally it for the server side. And when you create this, you can now start the server. And run the server will be ready to start. And every time we refresh this code and make a change, so the server is ready, and we've basically started the server. So we can basically run to do some of the magic of requesting data, and we can see how we can start doing things in our database. So I think we shall not do this here, but we shall now go to a real life application, just not to say to waste time with applying some of this stuff here. But basically, I'll just quickly go to the server so we can see. So this is the GraphQL API. And the GraphQL API now, we are going to try to perform these actions. Making a request. So we are neglecting this user interface that the client sees. We are going to make the requests manually, and then we see how they can be fetched from a database that we have connected to. So the GraphQL API is right here, and it's basically waiting to do something. So write an operation. So right now, our fields are here, and we can start to inspect these fields. So we made all the fields. We said there's going to be citizens in our database, and each citizen will have a name, an age, is he flagged, the driver's license, and of course he has a NIN. So the NIN is another object. So we can enter that object, and the NIN also has a NIN number, issue date, expiry date. So we can quickly make a simple request here, and these are called queries. So let's go back to the root. So we can say perform a query. Find for me citizens. Let me just go to query citizens. Yep. So we can say query for me all the citizens, in maybe Uganda, and we can define what exactly we want to query in these things. So we can say query for me when you return for them, return for me maybe the name. For each citizen, return for me the name. Is he flagged? So maybe Nira just wants to find out which citizens and what's their flag status. Are they criminals or whatever? And then we can, check for the data and the response. So the response will come back because I didn't create the database. So it's trying to check and it's saying, I'm looking nowhere, But that's basically how you request for the information. So you request for information and then you do something with it. So of course, this is not done by the user, it's done in the back end. So enough with the technicals. I'm going to demonstrate this with a live application that we can actually look at and play with. So to quickly rush back, I'll just quickly pause for a minute, just for a bit, and then we can have a few questions. I don't know if there are some questions from this side. If there are no questions, we can quickly get started. So I'll share a URL of the system we're going to test, and it's called VLAN. So it's an e-learning system that we've been building. So it's an e-learning system that we hope will be used in Uganda for a couple of things, especially during COVID, and the online landscape has been tricky for teaching, and education has basically been paralyzed. So we've been doing this as a side project for a certain startup here, basically to provide a solution for COVID, paralysis for COVID. And our system is able to do live classes, file management, building content, recording sessions, and role-based authorizations, providing feedback. So this system is actually live. You can actually go and test it if you want to, but you'll need to be accepted by one of our admins to join the system. And I'll quickly type this in the chat. Then I'll let a couple of you come in. I think I'll just allow maybe about 10 people just to. Sorry, my chat is here. So you can find that website in the chat and you can give it a try. So the e-learning system, we're going to test all these technologies now in action. So when we log in, this is how it looks like. So what we can basically do, let me try and delete this subject so we can quickly start from scratch to see how things are created in this graph. So when you enter a system, this is how it is. So I'm going to demonstrate proper information management in an example of like an e-learning system and how all these technologies come to play and how all the requests are made. So maybe I can just quickly, GraphQL, can just quickly try to query the server that is basically live, but I'll just quickly run back here. So every time you do an operation, can we do something with that information intuitively and store it better? So I'll keep making an analogy to Nira as a database. So let's say this is an operation to create a user inside the Nira database. So this could be the attribute, maybe the username, the Nira ID, his level of employment, is he executive, is he entry level, is he professional, different information. So every time you put this information, can we store it in a very interesting way? So right now I'll quickly, let me also just open up the database so we have all of them open. Okay, so coming back here, let's just create a subject. So let's say graph databases, just exactly what we've been working on. Graph databases. This is an introductory course on graph databases. So the level of study, let's say we are teaching maybe primary kids about this stuff, and the curriculum, maybe it's UNAIB. The year of study, maybe it's I think we use grade, maybe grade 1, grade 3, maybe primary 3 kids. And we're just saying this subject will start maybe next week on 10th of April, and it ends maybe sometime in May, end of May. And it's a course that we have just started, so we can choose an enrollment code, generate one that we can send to our students later. So we can say this subject can be visible, whoever enrolls will find it available. So we create the subject. So what's happening is we've made a request. So something has happened between our client application, which is this, the GraphQL that sent our message to the database to do something. So we can start to visualize what's going on in the database. So the database has a couple of things. I can, without distracting a lot of information that exists, I'll just quickly check the nodes, all the teacher nodes. So these are the nodes that coincide with the type definitions that you defined. So we can start to traverse some of the information. So we can say, let's check all the teachers. So this is a query that just says, find for me all the nodes that have that are basically teacher nodes. And so these are all the teachers that we have in the system. And if just expand this a bit, so I can look for my node. I think this should be me, Gumia. Yep. So I'll just ignore all the teachers because I don't want to disturb all the other teachers and whatever they have created in the system. So we have me as Kevin Mogumia, and he created the subject called Graph Databases. So I'll quickly open that system so that we can, I think, see it in action. I think that should be Learn App. So we can actually see how this relationship happened on a real life application. So the type definitions, we have a type definition. Every student, so this is actually a teacher. So a teacher can create a subject. So how do you define this? So we made something called a teacher. So there's a type definition in our type definitions called teacher. This has a teacher ID, a user ID, when the teacher was created, his authentication name, middle name, last name. But let's pay attention to the subject. So you realize that the teacher can have subjects that he owns. So these subjects are a link to another type definition called subject. So we have linked up a teacher and subjects via a relationship called create subject. So we're actually utilizing this relationship. And the subject is actually also an entity in the graph database. So I can quickly run to the subject. So the subject is here. So we have just linked up a teacher and the subjects you can have via this thing. So a subject can have a subject ID, created that, and all this information. And of course, we can also build a relationship to the other side. So teacher who owns this subject. So we have the relationship, this teacher created the subject, the students that are enrolled in this subject. So we build all the relationships of this subject with the teacher, the students enrolled, the prerequisites of this subject, the lessons, assignments, assessment. So you're going to see all these relationships, how they actually happen as we keep building the graph. So right now this subject is plain. So let's keep going forward. So we have graph databases and some information here. And this is the information we have about our subject. I don't know if it's visible for everyone. I'll just try to maybe expand it a little bit. All right, so we have some metadata about the subject. So we have some details, students who are enrolled, the subject statistics, and different information. So all this information is actually being fetched from Neo4j in real time. You don't even see it happen, but the requests are being made and the transactions. So all this information is actually stored inside this one node. And I think we can have a quick look at what is basically inside here. These are the attributes that we basically created that are basically following this type definition. What exactly a subject is supposed to contain for a teacher, all of the attributes, his first name, and all this information. So we get it systematically and then do something with it. So let's try and make a query here of, this is the API. Yes, so let's try and just show how this query can even be done. So let's say we are querying for teachers, and I show we can fetch some information intuitively. So we say we're going to query teachers. Yeah, so I'm saying find for me all the teachers in my system. And for each teacher, give me his first name, give me his last name. I'm interested in the subject each teacher is teaching. And for each subject, you need to provide other attributes because that's also another entity. So for each subject, I want a title. I want maybe the curriculum. And I want to know if those subjects are visible or they are not visible, you know? So we can keep going. We can keep saying that for each subject, give me the lessons in that subject. So we can say, give me a lesson and also the lessons connected to subjects. So we are trying to, you see how you're walking through the graph to request for information. So you're saying for each teacher, give me the first name, last name, and give me his subjects. But for each subject, give me the title of that subject, curriculum, is it visible? And for each of those subjects, give me the lessons in those subjects. And for each lesson, maybe give me the lesson ID and the title. Let's just stop here. And then we can query. So the data comes back, you get a response. And this response came back from the Neo4j database. So this response is actually, it's talking to this side of the application. So this information came back and we can always delete whatever we don't need. Maybe we don't want the first, the last name, so we can remove that and make the response again. It's very quick. You know, you get the first name. So we receive an object of teachers, and each teacher has some information. So Kevin has some subjects called graph databases. The curriculum is UNEB. It's visible because we made it visible. It has no lessons, as you realize there's nothing. But maybe there's some other guy called Kelvin. He has some subjects called software engineering. It has a lesson, and this lesson is maybe called the environment setup. There are a lot of other teachers in the system that are basically utilizing the system. So this is live data that actually exists in the system, and let's keep populating. Let's pay attention to just the teacher that we are working with at the moment. So let's build some more information. So let's create something. Let's create our first lesson. So what we're going to do is create a lesson. So the first lesson is how to build a GraphQL API. So this lesson is about building GraphQL APIs. And then I can say maybe it's happening sometime the first week. And then we can say learn how to, these are type learning objectives, learn how to create type definitions. We add that objective, learn how to create resolvers, to initiate or to transact the requests performed by the user. At that, then learn how to create server. So those are enough objectives for now. But basically, what are we doing now? Why are we even talking about graphs? Why are they powerful? So where can AI come in here? If we build this lesson and the students start seeing this lesson for this subject of graph databases, so we can investigate all of the text inside these fields. Maybe we want to recommend textbooks for this student, maybe from Google Books or all these online resources automatically. So every time a lesson is created for you, we recommend for you maybe 20 textbooks. So we can be able to analyze the text in each of maybe the lesson description and the lesson title can give us what this lesson is about and also the learning objective. So we can analyze all this information and the relationships between whatever is coming in, and then we do some analysis, and then we say, based on this analysis, we think the student needs books related to GraphQL or graph database. So you start getting recommended books. And this is exactly what shopping websites do. Every time you buy one product, they can predict what you're going to buy next. So you could buy saucepans, on maybe ShopRite online. Let's say they have a ShopRite online store. So when you buy the saucepans, they'll basically try to predict what else can we show this customer next before he leaves our website. So as soon as you add the saucepans to your cart, you start seeing things down there. People who bought saucepans also bought spoons. They bought some spices. They bought some meat. So they try to push you in because there's some analysis going on behind. So there are people who have bought what you've bought before, and after buying what you bought before, they bought some other things. So they are using information from those users to predict what you might buy. So that's basically what's happening. So every time we build a lesson, we want to do some analytics and provide some interesting recommendations for students. So it's just to personalize the learning experience of the student. So of course, when we make a lesson, we can categorize it into a unit. It's like a course unit. So you can have a bunch of lessons in one unit. It's a feature we're still working on, so it's not yet available. And of course, we can also make this lesson visible. Why not? We can upload a file or not for now. So let's create a lesson. Perfect. So our timeline is growing. It's going to start growing. So we have a concept called a timeline in this e-learning system. And this timeline basically allows you to see whatever you're going to be doing in your system, whatever you're going to be utilizing, all the courses, all the assessments, instead of seeing a calendar, because calendars are usually ugly and they're non-intuitive. But what if you have a timeline that tells you after lesson 1 on April 21st, what comes next, what comes next? So let's keep investigating. As we are doing this, we need to keep traversing the graph. So Mugumia created subject, let's keep going. So we have now built a lesson. So you realize that this subject graph databases has a lesson. So this lesson also has some attributes. So the lesson currently doesn't have anything. So we can quickly inject in some information. So when we go to the lesson, of course, we can change its visibility. Maybe you don't want your students to see it now. The semester as it started, you can turn on visibility. So all these things are happening in real time. But there's a middleman. This guy is doing everything to talk to this guy. So with the lesson, we can now start injecting in some information. So what can we do? So the lesson is here. It's called Graphql Api, and we know it's visible. So there are no assignments attached to this lesson. So it's good to have assignments and assessments attached to a specific lesson. So if students perform poorly in that assignment, we can be able to predict what's the best way to help them. So we can do some analysis and know, recommend the best textbooks, recommend poor textbooks. We can reach out to the teachers, other teachers who are teaching this subject, and we can maybe call them for help. So schools can even collaborate. Maybe students are struggling with math in Masaka, but there's a teacher who is utilizing this system who is very good, with math in Kampala. So they can always collaborate. If students are failing math, we can look for other teachers who are teaching that, and then we analyze the assessments, how people are performing. Then we can maybe introduce that teacher to provide some content to this site that is lacking. So let's add some information here. I can see some questions coming in. I'll quickly address them as to this. So we can always update some information. We can update the lesson details and all this stuff. We can, of course, delete this lesson, change lesson visibility. But let's do something. Let's add a file. Just a simple, let me just say, quick file. Maybe pipe. Yeah. So we upload a file, just added a file, and then we submit that file. Just a very simple, quick PNG. So the lesson, so every action we are doing, we're actually building a graph. So that is the goal, build a graph on whatever we have so we can store it more intuitively. So now we have this lesson, and I think if we expand it, let me just first collapse it, expand it, how to build the GraphQL API. Yes, it has this file. So the file is available. And this file is not actually being stored in this database. So there is something that you need to know about graph databases. They are not allowed to store, they're not good at storing blobs of data. So a blob is just a file, so you can't store files inside this, not good. So you can store the metadata inside, like things about that file, and then you provide the reference to where that file is stored somewhere else. So this is actually stored on a different server somewhere, Google Cloud. And we can inspect the URL. So we are just storing some metadata, the file ID, the name of this file on the server where we're storing it, its name, the real human readable name, and the type, and then the URL. So you can realize that this URL is actually taking us somewhere. So we can literally just, the same way we're requesting for information, all we are doing is we are saying, find for me all the files and find for me their URL. And that URL is what we are basically using to give the user. So they don't even have to care about where we're storing the files, how it's happening in the end. For them, they see their lesson files here. And when they hover, they'll be redirected to their link. So when you basically click this, it should take you to a PNG of what was happening. It's a previous presentation I think I had a day ago. But yeah, if we delete this file, things are happening in real time. So right now, this, we collapse it. Yep, it's not seeing the file anymore. So we are here, and then there's no file. So what else can we keep going? So we can keep going. Let me just put back that file so we can keep populating our graph, and then keep going. So every little thing. So we also have live sessions. We've integrated live classes inside our system, and you can create a live class. So the live class, let's say we are going to build a session and we are just getting the session name as the title of this, but maybe we shall just say type definitions. So this is strictly about type definitions. And session ID, you can say welcome message, welcome to my GraphQL API, live session, type defs, quick, and then you can customize. So you're customizing all these things and everything is being done in Neo4j also. So allow recording of a session, allow moderators to start for recording, allow time session, limit the number of participants, disable students' webcams. These are all the things that you need in an e-learning context because you don't want people to just come on and everyone has their webcam. So you can actually say, everyone who comes in, I don't want their webcams on. Whoever comes on, I don't want their microphones on. Mute everyone on start. Let me see, I want people to just keep talking, allow moderator, so we can disable the private chat because how students are, because this system is being used by young kids and universities and whatever. Universities, they might not do a lot of chit-chatting in private chats, but kids can do a lot of playing around. We can disable the public chat. And and then when you're ready, create the live class. So what happened is basically we are actually connecting to another external service. So GraphQL allows us to talk to our database here, but also talk to other servers. So we have another server that manages everything about live classes. So I'm in this meeting and I can literally start another meeting without interrupting this one. So this one, the students are able to see this session and it's untimed at the moment. It's available for them to join and the recordings will appear here when they're done. So everything will be done automatically. We do the logic using a graph to populate everything. So if we go back here, we can check this lesson and I think let's just collapse this and come back again. So the lesson has two nodes now. It has the live session, it has the file. And this live session is in progress. We can check some details about it. Its ending time, it's not expired. Its ending time is, there's actually an ending time. It says that it's untimed, so it won't end, but every time we create a session, we utilize resources. When a teacher creates a session, right now we have given you a slot on our server. So if you don't join and use it, you're wasting our resources. So if it stays idle for 5 minutes, it will just expire. That's why it's untimed. But yeah, just a simple point to note. So we can join this class. And when I join it, I won't share just to disrupt things, but I join as the user here. Neo4j talks to this service to basically input all that information that we basically put. And this one is called vLive. So there's a public chat and students won't chat here. If I've disabled it, they can't. But if I have done so, and we shall demo this, I'll let some of you join the system, and then as students, and then you enroll to this subject, and then we can test it out a bit. But basically, I'm a teacher, and all the students that come in will be enrolled here. There's shared notes, and students can talk to each other, these shared notes and whatever. And we can start the recording just for the sake of giving it a try. So we can always upload a presentation. So I can quickly, maybe upload just a quick file here. And as that uploads, I'll just keep talking back about this. Yeah, so basically, as you keep, every action you do, you keep building the graph. So this is for lessons, yeah. And yeah, so now we've basically put the slide so the teacher can always, collaborate on the whiteboard. Different students can point, students always like asking that, teacher, when was the get there? Oh, I need to understand this, so you let people point and, I can tell you, Kagua, can you point? So you just turn on you and I can see your pointer that you're pointing here, and then we can guide each other. So these are some of the things that are in the system. And yeah, so I was trying to do this recording and I'll just stop the recording and cool, let me just end this meeting. So when I end it, I kick out everyone and Neo4j knows that and it will talk to my application to kill the server. So it kills that and it's now expired. So all that happens real time. So this says no recording available. If you recorded your session, it's still processing. So Neo4j has told there's a server it's talking to that, hey, for this live session, there's a recording coming in, but it's processing. Whenever it's ready, I'll tell you when it's ready, then I give it to you, and then you can show it to the users of the user interface. So this is basically what's happening. So we can quickly create something more interesting, maybe an assessment. So for one assessment, we can say maybe after a week, after they have learned how to build the GraphQL API, we can say beginning of term quiz. Or we can just say quiz 1. So we say this is quiz 1. Maybe it's 15%. Weightage, it contributes only, maybe contributes 90%. And this assessment maybe is going to be first week of May. It's for 1.5 hours. And I'm not going to make it visible until that day. And I'll upload the files, so create the assessment. So the student, the timeline keeps on growing. He knows that, oh, I have lesson 1 on April 21st. I have an assessment on this day. So you can keep building, and then let's create also maybe a group design project. Group design project builds a full scale Grunt stack up. This is going to contribute maybe 20%, and the weightage is maybe 10%. Small for a group design project. Maybe you're going to do it for the whole of May. After that assignment, maybe on 16th, up to maybe 29. The difficulty, oh, my bad, sorry. 29, yep. So maybe it's medium, and it's group work. Assessment visibility, we shall make it visible when it's available, just to let everyone start in fair time. Some people might start early and some might start late, so create assessment. Yeah, so I actually created this here. So now we have a lesson, we have a quiz that is coming back, we have an assignment that is coming up. So for our quiz, we can have the students who are assigned, graded, those who have submitted, and we can go and start marking them, and then we do some stuff, and we can upload the assessment files. So let me just upload maybe just a quick file here. Yep, submit file, that's an assessment file, and yeah, so let's go back to our graph to see how things have grown now. So our lesson is here. We have an assessment. We have an assignment. We have a lesson. So we almost have things growing. So we have for the assessment, it has a file. So you can always know if it's visible, if it's invisible, depending on what you did. So this group design project doesn't have a file because we haven't added any. The lesson has a live session and a file, as we saw. And okay, the recording is not yet ready, but it will be ready as soon as when we check back, we shall find it sometime ready. Yeah, the recording is now available. So the recording that we started recording is now available. So Neo4j has talked to this guy, oh, I finished processing, it's a 3-minute, and that recording is stored, and you can always inspect what was in, yeah, when I was talking and all this stuff. And you can always, so it's not just a player, but it's actually a player that has the slides that we're used to present. So you can always go back to a specific slide and you start from there. If you were on slide 5, you can quickly run to slide 5 and you see what the teacher was presenting in the video. So this is the recording. And yeah, that's basically how we link up all this information. And so in the end, what's the goal of this, whatever we are doing here? The goal of this is to have all the information linked up in, we're just building a knowledge graph. And I think if we expand this guy again, we should be able to see that live session record. Yeah, so now it says that Mugumia created this subject has this lesson has this live session, and this live session has a recording. So it just keeps growing. It's endless. It's very, 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 very big. And you can now start linking up. When your students come, they'll connect to this subject. So they will go under the has enrolled into this subject. That student has comments on some post that is making, some questions he's asking in the forum. So it's a very big graph. And the goal is to building something similar to the Google Knowledge Graph. Remember how I said this stuff is everywhere? So Google does the magic of the search engine, whatever we do, because it has something similar to that. So it has what they call the Google Knowledge Graph. You can read more about it, but that's what it basically does, and you can have the magic. So imagine as a country, all your data is stored here. If we see someone on a CCTV doing a crime, we know their name, we know their driving permits, we know the cars they have driven. So there are some privacy issues, of course, if a government is given this much power. So there are issues that also come up with this. And yeah, so I'll just quickly run back to the chat to just see. Okay. Quickly run back to the chat to see what's coming. Okay, so there's a question. I don't know if I missed it, but what are the pros that make GraphQL stand outstanding? If GraphQL is important for JSON data through API, can you use GraphQL on top of MySQL? Yes, that's a very good question, Peter. So basically, GraphQL can actually be used on top of all these existing databases like MySQL, and there are a couple of implementations for that, but it's very possible. You know, GraphQL, what makes it special and what makes it outstanding is that when you choose to work with graphs, so remember you're trying to store your data as a graph, so it's best not to use a mechanism that doesn't operate very well with graphs, you know? So you store in graphs, at least use something that is very good for querying things as graphs, you know? When we made this request, we're actually trying to build a graph. You know, when we said, find from the teachers, we're just building a graph. It's like we are walking through here. We're just saying, find for me this guy, get for me this, find for me the assessments, and the assessments pick only those that have this attribute. So we can walk and then we do this. This is very powerful to do with GraphQL because it allows you to query for information exactly how you need it. And I think if we go to the GraphQL documentation, just the GraphQL website, that is something they brag about. So they say this is a query language for your API, but it allows you to query and ask for things exactly how you need them compared to REST APIs. So what they brag about, they say you describe your data, which is what we did first. You describe the entities. So here they are saying there's a type definition called project, has a name, a tagline, and contributors to that project. So the next thing is asking for what you want using something like GraphQL, which is what they're bragging about. So GraphQL will request for these things. So you're saying, find for me a project whose name is called GraphQL and return for me the tagline. And then you get the results. So the results are predictable because you only get what you ask for, nothing more, nothing less. So this is in comparison to something like, SQL is not a good comparison to compare with GraphQL because they don't do the same thing. Neo4j is a good comparison to compare with SQL, but GraphQL should be compared with something like REST. So I think your question probably might have been asking what makes maybe GraphQL stand out. I don't know if that is GraphQL outstanding. It's getting information in predictable ways, and we can even see how some of this information ever comes back. Maybe I'm just showing the user interface, but if we ever go to network, let me just go back to maybe this place, and we just run a refresh. So we shall see how the information comes back every time you request for it and what makes it powerful. So the requests we have made, so we are basically saying, find for me teachers. Let me just minimize this to a phone view. Hope it's still clear. Okay. So here it's like I've written a query inside the GraphQL API. So here we're just returning the data and we are saying we only need specific information to render this page. We can't get everything. We don't need recordings on this page. So with REST endpoints, how they request for information, they request for everything. And then you filter out only what you need. But you're wasting resources. You're wasting people's data on their phones because they request for what they don't need. If I'm on a page that only needs the subject name, why do you need to fetch the lessons, the recordings, the other teachers? And this information is not being shown on the page. Maybe it's being shown in the future, but it's not necessary. So GraphQL allows you to ask for only what you need exactly when you need it and in a predictable way. REST endpoints, you need to create an endpoint for everything you request for. For the birth name, everything you request for will have to have information. we'll have to have a mechanism of fetching. So for this, whatever data is actually being used here is actually here. It came back from this GraphQL endpoint. So we made a request to our GraphQL endpoint and we got back a response, and we can preview the response, the name of the teacher. So we asked for, give me the teacher who has this teacher ID in this URL. That's the teacher that came back. So it's one teacher, his details, and of course the subject. So he has one subject and we can enter this subject. The subject has certain assessments. It has one assessment. It has one assignment. It has some lessons. It has one lesson, and it has different things. So this is how the information comes back. It's because we've written a query. So this query is almost the same that was returned here. But whatever happened here, we've designed it in the back end. That when someone comes to this page, we just refresh and request for that information. Please let me know if I've answered your question, but I can provide some documentation to what makes GraphQL powerful. But yes, it can be used on top of MySQL. Let me go to another question. I request a recording once can be shared. Okay. Okay. All right. Okay. I don't think there were any questions there, but I'll try to let some people actually join this system, and I'll give them a role of a student to enroll into this subject so that they can we can do something just a bit more intuitive. But feel free to drop in any questions that you need. I think Anna, you've made a request to join the system, so I think I will give you a role of student. So I'll try and give people a few minutes to try and go to VLAN and maybe sign up to the system, and I'll be able to give about 10 people some roles as I wait for some questions. And yeah, we can be able to see where to go from here. But the overarching goal of whatever we have basically discussed here is that GraphQL and graph databases give you the power to store your data more intuitively, so you can do a lot of interesting tasks rather than have tables that are linked together in non-intuitive ways. You now have information the way you think about it as a human, with these relationships, with these connections, and you are able to, derive insight, because it's not just useful to store information that you can't derive insight from. So if you have a way of, if this is easy for you to derive insight, it becomes quick and easy, when you look at a lot of information about whatever is coming from here, the CCTV can look at a person, but it starts fetching information from NERA, from police, from Ministry of Health, from different departments. So the way we store information currently is not good. Imagine a CCTV could see you hit by a border, and it quickly sends a report to the closest hospitals with your blood type, because it's got from Ministry of Health, maybe from some records, your passport number, the location where you've just crashed, and an ambulance comes. This is stuff that happens in most of these countries because they're aggregating a lot of information from so many sources to make a decision. But every time you link up so much information, it can become very, very, very tricky to analyze it. So when you use graphs, it makes it easier to basically operate. Yeah. So that should provide some context. So I'll try to refresh this and see if some people have signed up to this system. Yeah. So I'll just let it be here, but feel free to go and sign up to this to get started. I'll try and give you a role, and then we can go ahead see what to go from there. Otherwise, I'll just await a couple of questions for that, for whatever we've just discussed. Some clarity, extra resources, what might be needed, where to go forward. I'll try to share the code of a small project on GitHub, and then I'll share it, and we shall probably add it as a comment on the YouTube video, so that you can have a quick spin up of maybe data from maybe Ministry of Health, Ministry of Security, just some quick mock-up data to show you how all of these things can be linked up. Yeah. I think if there are no questions, I think that should be it from me on the technical side. And I would like to thank you. I hope it was a bit helpful. It was a bit more on the technical side, but I try to provide some intuitive examples of, where it's applied, what can we do, where can we go, and some bit of background, so that at least everyone at least knows an idea of what this is, and where we can, where you can start from in case you're ever interested in doing maybe research or diving into the development tasks for this. Yeah. So thank you so much.
All right. Thank you so much, Kevin. This has been just thrilling. We can't even imagine that we've been here for nearly 3 hours. Thank you so much. It was such elaborative and very expansive, but in what you would call a short time. But we're so grateful. If we're just within one place, I would call for a round of applause. But we are all very grateful for this. You've taken us, you've given us a background information about graphical databases, you've given us applications in machine learning, you brought in some cases of how we can apply this in Uganda, especially on the issue of security and monitoring. You exposed us to some technologies, like GraphQL, React, Apollo, Jeff, and then you've given us some applied case on the VLAN. We're really very, very grateful for this, and I believe that whoever's been online has benefited quite quite well. With the big data, this era that we are living in, a lot of data has been created. Just as you mentioned, we have mobile phones. Wherever you go, it's picking up data, picking up GPS. We have smart devices now. We have smart homes. You have your fridge in the house; it's picking up data. You have the TV; it's picking up data. You have hospitals, you have everything, but all this data is created. Where is it going, and what can we use it for? So in data engineering, there's what they call the 5 V's. The volume, like I mentioned, data is created everywhere in huge volumes. And there's what is called variety. It's coming in, in diversity. Some is structured, others unstructured, others semi-structured. But the other 3 important V's are the value. How do you benefit from this? What value can you get out of this? And if the value is there, at what speed? That is the velocity. How fast can I get this data? Yeah, if you're putting into consideration the issue of latency. And then the last V is the veracity. How accurate is this data? So when you look at this, is what makes technologies such as graphical databases to be quite important. And we are happy that we've been introduced and we've somehow been given the entire life cycle, the background, the technology, how we can be able to implement this. So I really want to thank you. You've been such a good audience, sustaining this all through. I know some have been off and on, and you have really endeavored to come back. I thank the community at Inkumba, including both the students and the staff. I recognize the presence of the HOD, Hilda. Then I recognize, I see some staff that are coming in from Makerere University Business School. I see some students online. I see some of my former students, some other university. I've seen Edmond has been very active in the chat. and many others. I really want to thank you for this. And the questions that you brought in have been good and making the discussion quite healthy. I would like to mention again, the School of Computing and Informatics is a new school in Kumba University, and this has given us a good footing to start off. And as the VC mentioned that there are going to be several webinars and seminars that will be within the university environment. So we will call upon you to always, be our audience, always come in. We requested you to register your email addresses so we can, reach you more directly. And we also have got a YouTube channel where this video has been streaming live and has been recorded. So feel free always to go in there and then view and make comments, and still you can register your addresses there. We can always reach you out. So for now, I would like to again call in the Vice Chancellor to come and give the closing remarks and then perhaps close the session. Thank you very much. Over to you, Prof.
Okay, thank you so much, John, for that. And to me, I can only say thank you, Kevin, for a very, very good presentation. I'm sure all people online can attest that whatever they got this afternoon has been really, really, really good. We shall share. The YouTube video is there for you to be able to access all this content. And we shall continue engaging Kevin. Those of you who are really interested, he's a young man interested to give knowledge to whoever wants it. So Kevin, we are very, very proud of you. Whatever you are doing there, the candle you are lighting, wherever you are, we can say we are very proud of you as Ugandans. Just keep doing the right thing. You are just in the right direction in terms of technology development. So for us as Nkrumah University, we are very proud of hosting you this afternoon. And we shall continue engaging you as you nurture these are the young ones to make sure that they can be like you are, because you are an amazing facilitator you've been this afternoon. So thank you so much. And to all colleagues that have been attending, thank you so much. Come again and again. As I said earlier, we are here to bring you all what you need to have in terms of the trending technologies of this era. So I wish you all the best. I don't know if there are any questions that are popping up here that Kevin wants to, but there's none, I guess. There's none, I guess, and I think let's have a great afternoon and evening, morning, wherever we are, and we wish you all the best. Thank you, Kevin, and a good evening.
You're welcome.
We can leave at leisure